All right, welcome to The Explainer. Today we're diving into a project that's trying to, well, fundamentally change how we and how AI deal with information. And look, I'm not just talking about a slightly better search engine or some new app. We're talking about adding a whole new dimension to it.
So just think about this for a second. What if instead of endlessly scrolling through feeds and documents, you could actually move through ideas? Like, you could literally walk up to a concept, see what's related to it, just by, looking at what's nearby. You'd be able to grasp these super complex connections just like you were navigating a city.
And that's the grand vision, right there. It's for a project called Knowledge 3D, or K3D for short. Their goal? Well, it's twofold. First, they want to build the Minecraft for cognition. Think about that. An open world where the building blocks aren't dirt and stone, but actual pieces of knowledge. And second, they're aiming to create the operating system for something called the spatial web, basically a 3D internet you can walk through. It's a crazy ambition, turning abstract data into a universe you can actually explore.
Okay, so why? Why go through all this trouble? Well, the core idea behind K3D is that the way we do things now, it's holding us back. We're trying to make sense of this massive, multi-dimensional world of information, but we're stuck, caged on these flat, two-dimensional screens.
And the difference is, well, it's pretty stark when you lay it out. Right now, most AI processes information like we read an ancient scroll, just one word after another in a straight line. And it has to use these incredibly complicated mathematical gymnastics to figure out how things are related. K3D's approach? They want to build a web, a whole spatial universe where knowledge is physically represented, and that completely changes the game. It shifts the problem from super complex math to really simple physics. If two things are close to each other, they're related. Simple as that.
All right, so how do they actually build this universe? It all boils down to one simple but incredibly powerful rule. It's basically the law of physics for this entire space.
And here it is. This is the absolute heart of the whole thing. In the K3D universe, spatial proximity equals semantic relation. In plain English, the closer two things are to each other in this 3D space, the more related they are in meaning. It's such an intuitive idea, but the implications for how an AI can understand and reason, they're just massive. So every single piece of data you can imagine, a word, a picture, a sound clip, even a memory, becomes what they call a node. And visually, these nodes look like little stars, all floating around in this digital space. But here's the cool part. They're not just random dots of light. Oh no, they speak a very specific visual language.
The shape of the star itself tells you exactly what kind of information you're looking at. So a tetrahedron, that's text. A cube, that's an image. An octahedron, you're looking at an audio file. And it goes on like that. It's this standardized geometry, which is brilliant, because it means both humans and the AI can instantly understand the type of data they're dealing with, just by looking at it.
And it doesn't stop there. Shooting out from these stars are these light rays, and they pack in even more info, all the metadata. So for example, a really thick ray might tell you that you're looking at a super high-res image, maybe a 4K video. And the length of the ray could represent, say, the duration or the file size. A really long ray, that could be a full-length movie or a 1,000-page book.
Okay, so you've got this entire universe filled with these data stars. Awesome. But how do you keep it from just becoming, cosmic chaos? How do you organize it? Well, to manage all this, K3D does something really clever. It mimics a system that's already inside all of our heads, the way our brain separates short-term from long-term memory.
So K3D has this dual memory system. On one hand, you have the galaxy. You can think of this like your computer's RAM or your own working memory. It's this dynamic, constantly changing, temporary space where all the new information and raw data gets pulled in and just kind of floats around. And then you have the house. The house is the system's hard drive. It's the long-term memory, stable, permanent, and very, very structured.
Okay, so how does stuff get from the messy, temporary galaxy into the neat, permanent house? This is my favorite part. It's through a process they call the sleep time bathtub. And yeah, it's pretty much what it sounds like. When the system is idle, when it's sleeping, it runs these consolidation processes. It basically scoops up all that raw, floating data from the galaxy, starts finding patterns, compresses it all down, and then neatly files it away into the structured objects inside the house, just like our brains do when we sleep.
I mean, the architecture of this whole system is just wild, super ambitious. But the story of how they're actually building it,
That might be even more fascinating, because this is not your typical team of software engineers sitting in an office.
Nope. It's being built through a process they call vibe coding. Here's how it works. You have one human visionary, a guy named Daniel, who's like the orchestra conductor. He sets the high-level vision, the vibe, and then he unleashes a whole swarm of collaborating AIs. We're talking models like Claude, Grok, and Kimi, and they work together to write the code, debug it, and optimize the whole thing.
And you can actually watch this happen in their public development logs. It's wild. Like, here's an example. One of the AIs flags a huge problem. A critical part of the system, the kernel, is a whopping 41 times over its super strict size budget. That's not a small issue. That's a total showstopper.
But then, boom, another AI, Grok, jumps right in. And it doesn't just say, oh, that's a problem. It proposes this incredibly sophisticated GPU-native solution on the spot. It's basically saying, hey guys, let's ditch this standard algorithm we're using and switch to this more advanced thing called affinity propagation. It'll work way better with our hardware. Just incredible.
And then it gets even crazier. A third AI, Kimi, chimes in and reflects on the process itself. It looks at this back and forth and calls it cognitive resonance. It's basically saying, hey, what we're doing here isn't just problem solving, we're amplifying each other's insights, creating a solution that none of us could have come up with alone. The AI is literally philosophizing about its own creative process.
And the performance that this AI team is shooting for? It's just extreme. Their target for core operations is a latency of under 35 microseconds. We're talking 35 millionths of a second. To put that in perspective, that's not just fast. That's a level of responsiveness that, for a human, would feel completely instantaneous.
So you take this radical vision of a spatial universe for knowledge, and you combine it with this completely new way of building things, with AIs building an AI, and you start to see the shape of a really fascinating and, frankly, a very different kind of future. I mean, the potential shifts here are just huge. Think about it. An internet you walk through, not when you click through. Imagine an AI where its reasoning isn't some mysterious black box anymore, but a visible path that you can actually follow and interrogate. We're talking about a real symbiosis, where humans and AIs are co-creating things in a shared mental space. This is a future where knowledge becomes something you experience, not just something you read on a page. Look, K3D is a huge, audacious bet. It's trading the simplicity we have today for a future that promises incredible density and intuition. And it really forces us to ask a pretty profound question. Are we just looking at the blueprint for a new kind of internet, or could this be the blueprint for a whole new form of intelligence itself?